Okay, in this video, we're going to go over some layer 2 principles. So really the point of this video is just to cover topics that we might have missed and just kind of bring it full circle with the layer 2 fundamentals before we get into some switching actually fundamentals, right? Because layer 2 is just the data link layer, right? Switching is layer 2. However, there's just more principles that are beyond just that actual Cisco switch. And we want to make sure we cover everything so that our students have the most knowledge. So we're going to start off with the term broadcast domain. So the layer 2 broadcast domain is referred to as the MAC broadcast domain. And what we mean by that is all the devices on the LAN that receive broadcast frames from a host all belong in that same domain. Okay, so our definition here, the MAC broadcast domain consists of all devices on the LAN that receive broadcast frames from a host. So why do we use this specific language here? Well, because we're going to learn about technologies like VLANs in our upcoming videos, where if we send a broadcast frame and we're a part of VLAN 10, users in VLAN 20 won't receive that. So if you're able to receive a broadcast MAC address from, let's say, your computer A and you receive one from server B here, you're going to be in the same broadcast domain. So really, this is also just a term in networking that describes networking nodes or devices that belong to just one network or subnet. Because if you're following these videos in chronological order, you know we've learned about subnetting. So as we can see here underneath our term here, broadcast domain, in this little network diagram we see one subnet. So all these devices also belong to that one network or subnetwork, and that's also one broadcast domain. So if we were to split this up into 1.0/27, 1.32/27, 1.64/27, three different subnets, and then we put each device into a different subnet, that means we would then have three broadcast domains all on this one physical device, this switch here, this geographic area. So again, broadcast domain also means one network. So a switch out of the box is really just one broadcast domain. And we're going to learn about this further when we go over VLANs, because out of the box, a switch is just in VLAN 1. But as we can see here with logical segmentation like VLANs or that 802.1q tag, which we're going to learn about, a switch could potentially have hundreds, or even 1,000 broadcast domains separated logically, okay? So now let's get into collision domain, because we see that this is also collision. These devices are also part of collision domains. So a collision domain is considered one physical segment between devices. So this is a physical concept, right? What we mean by this is that this computer A, and this, let's say, switch 1, share one physical segment. There's only one Ethernet cable between this computer and this switch. And let's say this is connected to this port here. Maybe that's gig 0/1. That's a collision domain, meaning there's send and receive information going back and forth between just this port and this computer at the actual interface level, at the actual wire on the hardware. So one connection from a user's network interface card to a switch port, individual switch port, is considered a collision domain. So what does this mean? So if we have a 24-port switch, that means we have 24 collision domains on that switch. And why is this important? Because in an individual collision domain, we can send and receive, right? So in the past, we used to have devices called hubs. And this hub device, let's say it had 4 ports, and it had devices connected to all 4 ports. It was half duplex, which means you can't send and receive at the same time. And this entire device was just a single collision domain, which means that if both these computers try to send at the same time, you'd have a collision and you couldn't talk on that local area network. So that's why it's important to understand that a switch port, an individual switch port, is its own collision domain. Whereas the hub, the actual hub device, is just a collision domain. It's actually considered layer 1 as well. Okay, now let's go over a few fundamental concepts called carrier sense multiple access, collision detection, and collision avoidance. So have a deeper understanding of our switching fundamentals, we had to go over some of these legacy technologies and how they used to work. So before the use of full duplex on an Ethernet network or a link, right? Ethernet technologies would use something called CSMA/CD collision detection or carrier detection. Excuse me. So in a CSMA carrier detection network, only one node at a time can send and only one can receive. So what would happen is this carrier sense multiple access carrier detection could detect when two nodes try to talk at the same time and then would send a collision report back to these computers saying, hey, you're trying to talk at the same time. You can't do that. So we're reporting back a collision. And this would happen all with that Ethernet technology, right? So with the implementation of full duplex, we got rid of this issue, this collision detection. And then we have carrier sense multiple access carrier avoidance, which differs a little bit from collision detection. So in a CA network, the network nodes listen to see if the node sharing the medium is speaking. And if it is, it's going to wait instead of causing a collision to actually receive the transmission in full ultra send, right? So we see this a lot in our wireless technologies. So this computer Wi-Fi enabled is going to detect activity. If it doesn't find any activity on this transmission medium, it's going to send its RTS. The access point's going to confirm the CTS receipt and then complete its transmission. If it does detect activity, it's going to wait. So essentially what we're having here is instead of causing that collision on purpose, this device is actually going to just completely avoid, open up this Google tab, is going to completely avoid making that collision. Okay, and now going over our duplex. So we kind of went over this in the past few slides, but now we just have another diagram to show you, right? So we make sure we fully understand. So full duplex, you're going to send and receive simultaneously. And then half duplex, you're going to send or receive. And you can't do it, send and receive at the same time. And again, full duplex has better communication. And half duplex is going to create a lot of performance issues because it results in collisions. Okay, so how do we check the duplex on our Cisco iOS? So a couple different ways. We could do the show interface gig or fast Ethernet or Ethernet command, and then you identify which Ethernet interface. So we can see that command right here. And then we have the command show interface status from our privilege mode, which will also show you the duplex of all the interfaces on your switch. And nowadays, most NICs, most switch ports, they're set to auto, but they're always going to run in full, right? And if we have an issue with that, we got to be able to recognize that, oh, we have collisions, or we have input errors on our switch port. Maybe we should check the duplex, right? Okay, and then a little bonus. We talked about this in our earlier section, but MDIX. So in our modern networking, we don't have to worry about using crossover cables for our like devices. Remember, crossover cables would be T568 alpha on one side and T568 Bravo connection standards on the other side, which essentially flips the transmission and the receive pairs on our copper media of our unshielded twisted pair or shielded twisted pair. So without this MDIX technology or software implemented on our switches, between like devices, we need a crossover cable. But nowadays, and this is like, MDIX is old technology, right? Early 2000s, MDIX came out. especially on, I can only speak for Cisco devices, right? But with MDIX, which is just auto, you don't really have to configure it on your devices. You can just use straight through cables for all those like devices. Okay, so this was finishing up some of our layer 2 principles. In our next section, we're going to go over some more switching concepts before we start getting into VLANs and configuration. So thank you for viewing.